All right, today we're simplifying radicals involving division or fractions. So if I have a radical and under the radical it's a fraction, we can just separate numerator and denominator, take the square root of both the numerator and the denominator, and then I'm left with 3/5. All right, next one. What would we get for the numerator, Aurora? And the denominator? 7. So we can just separate it and take the root of each. Okay? The same thing goes as if I have a radical divided by a radical. If they can be simplified under the radical, we can do that too, before taking the root. So for instance, 12 divided by 3 is 4, and 4, the square root of 4 is 2. So it makes it a little bit easier. Hannah, you with me?
Yeah.
Okay. So Hannah, what would the next one be?
Would it be?
I want to hear your thinking.
I don't know.
What did I do up here? How am I getting radical 4? From 12 over 3. What does the bar mean? In a fraction, who can tell me what a bar means? Matthew?
Division.
It means division. So all I did was divide. What am I doing here?
Divided.
So 45 divided by 5 is
Oh, 9.
9. The square root of 9 is 3. So do you understand? We can divide under or we can separate. Yes.
I was gonna say, you also just do the 9 radical, or radical 9 times radical 5, and then just.
You wouldn't do radical 9 times radical 5. Not here. Oh, I see, under 45. Okay. So he's saying, what he's saying to do, sure, we can do it that way too. There's no one way. He's like, can we do, make 45 radical 9 times radical 5, right? All over that radical 5, and that's what you're talking about. Yes, we could do it that way too. So, 3 rules for simplifying radicals. The first rule is we leave no perfect square. We leave no perfect square factor in a radical. Number 2. So, I'm sorry, not before number 2. So, what perfect square is in 50? Yep, 25. Rad 25 times 2. And so, what's the root of 25? 5. 5 rad 2. Okay? That's rule number 1. Number 2 is we leave no fraction or decimal in the radical. For instance, this really means rad 3 over rad 4. What's the square root of 4? 2. Now, the radical, there's no longer a fraction under the radical. Does that make sense? Number 3. Most important right here for today's lesson, we leave no radicals in the denominator. We leave no radicals in the denominator. So I am going to multiply by what to get rid of that radical in the denominator? Rad 3. But we're not going to we're going to multiply by a fancy 1. Rad 3 over rad 3. Whatever's in that denominator, I'm going to make it my fancy 1. Okay, so I can, let me write it out. So I can use the identity property. Rad 3 over rad 3. Doesn't that equal 1? Then we have what? What does the numerator simplify to? 2 rad 3 over 3. Questions? Okay, so leaving no radical in the denominator. It's called rationalizing. Rationalizing the denominator. Now, they simplified first, Look at how how my PowerPoint got there. They're taking the square root of 4 is 2, then, but it doesn't matter if you simplify first or second here. As long as you get to the same answer. Questions? All right, can I move on? Okay, I'm going to skip this page. The big thing is that they want to remind you to leave no perfect square undone, like that 9 inside the 18. Okay. Sometimes when you multiply numbers together, you get a new perfect square. All right, so let's look at these 4. Why don't you guys try number 7 through 10? And number 10, how are we going to deal with that under the radical? What? Change it improper. Okay, you want to try it on your own, or you guys want to do the first 2 together? Okay, first 2 together. Okay, so what we're going to separate rad 5 and rad 9. Now, what do you think the best course of action is, Josh? Which is 3. This was an easy one. I didn't need to rationalize. Okay. And we're done. 5 rad 5 over 3. Next one, the denominator. Do you guys, why don't we simplify first? What makes up 8? 4 times 2. Now, 4, what's the square root of 4? 2. So I'm really left with this. What piece of radical do I need to get rid of? Rad 2. So I'm going to be multiplying by rad 2 over. It always has to equal a fancy 1. Now we are left with rad 6 over 2 times 2, right? Which is rad 6 over 4. Can we cross cancel or simplify radical with non-radical? No. Okay, next one, number 9. Number 9. Lily, oh, do you want to do these together, or you guys want to try these on your own? Okay, pause the recording and do them. Okay, let's separate them first. Radical on the top, radical on the bottom. We're just using our identity property. We're multiplying by a fancy 1. What do you need to get rid of?
The radical on the bottom.
Which is?
Rad 6.
So what's my fancy 1 going to be?
It's gonna be, your fancy one's gonna be a 1.
No, 1 doesn't help me. But how do I make that fancy 1 to get rid of the rad 6?
Rad 6 over rad 6.
Any number over itself is that fancy 1. That helps me with my identity property. So we are multiplying by rad 6 over rad 6. The new numerator will be what, Sophie?
It'll be rad 6 over rad 36.
And what's the square root of rad 36?
It's 6.
So it's rad 6 over 6. Whenever you do 2 of the same, it's going to be exactly what's inside. Now for the next one, we can't do it in the way that it's written as a mixed number. So what do I need to do to change it, Carson?
You have to make it into an improper fraction.
Which would be
12 over 5.
12 over 5. Okay, now there's no one way to do this. Let's say I choose to multiply. What do you think you want to do, Sophie? You want to simplify first or get rid of the denominator first?
Simplify first.
Okay, so how do I break down 12?
4 and 3.
And on the bottom, I've got that rad 5. So the square root of 4 is what?
2.
2, and I'm left with rad 3. And in the bottom, I still have that rad 5. Now, what would I multiply by to get rid of that radical, actually? I need to multiply by that fancy 1. By the fancy 1.
Yeah.
So what am I multiplying by?
You're multiplying by 5 over 5. Rad 5 over rad 5.
Yep. And now, look what's happening here. I've got 2 times radical 15. I multiply radical with radical. And in the bottom, what are we left with?
You're left with 5.
Good. Okay. I could have also done right away, I could have made it, if I was here, rad 12 over rad 5, I could have done and then pulled out that 60 is made up of 4 times 15 over 5. I end up with 2 rad 15 over 5. Do you understand? There's more than one way to get there. Here I simplified first. Here I simplified last. Okay? All right. Let's try 4 more. Go. Pause the recording. All right, now check your work. Okay, what are we doing on the bottom? Number 12, please, Rand.
That one you can just divide 3.
Okay, when they say rationalize, they don't want you to just divide under the radical. They want to see that you're clearing it. So that's the only time we can't. But if they say simplify, you're right. It is easier to just say 12 divided by 3 is 4. But to rationalize is to multiply by that fancy 1 and use the identity property, right? Rad 3 over rad 3, it's rad 36, which is 9 over 3 is really, is 6 over 3 is really 2. Okay, next one. We're showing rad 2 over rad 2. And we get 5 rad 2 over 2. Can we simplify anything? Okay, now the last one was a little bit, well, it's rad 2 over rad 2, which would be rad 20 over 2. And in 20, what do we have? A 4 and a 5. And that would be a 2 rad 5. But then we can cross cancel these 2's here. So much easier to just divide 10 by 5 by 2. But notice the directions. So when they're saying the directions like this, we want to see that you know how to multiply and use that identity property with the fancy one. All right, so these are getting a little trickier. What am I doing with these? 24, 25, right. Turn it into an improper. Now, how about if we, seems like the trend in my PowerPoint, they simplify first. What's the numerator? 5, so it's 5 over rad 3. Then rationalize. What do I need to do to get rid of that, Jesse Santos?
Multiply by rad 2.
No, rad 2,
3.
3 over, rad 3 over rad 3. Okay, then we get 5 rad 3 over 3. Questions? 16. 16. It would probably be the easiest, but they're not saying to simplify, so the easiest thing to do is 6 divided by 2 is rad 3. And we're just done. Of course, they're rationalizing. Don't worry about it. We get rad 12. I like the way you thought. Okay, questions? Did you see the way he did it so much easier instead of rationalizing? Okay, what about 6? How do we say this decimal? How do we say this decimal properly? 600. So if we can say it, we can write it as a fraction. Now that's really rad 6 over rad 100. And so what would that simplify to, Miriam?
That was simplifying to
Rad 60. I see a perfect square there. Perfect. Rad 6 over 10. If it's a perfect square there, don't rationalize it. Okay. Now, the next one, we could reduce right away, and that would be a 1 and a 2. And then I'm multiplying. But I'll just rationalize by rad 10 over rad 10. Do you guys want to try this one? You guys try it. Pause it and finish it. By rad 10 over rad 10, what do we get? I get a 4 rad 50 over 10. Now, rad 50 has what perfect square in it? So I've got a 4 times 25 times 2 all over that 10, which is the same thing as, 4 times what? 4 times 5, rad 2 over 10. Isn't that the same thing as, I keep doing that. 20 rad 2 over 10. Yep, to 2 rad 2. Okay, questions? There are 10 different ways we could have gotten there. So there is no right way. It's just, are you getting to the answer? Right away, I probably would have done this. I would have done this. Right away, I would have done this and said it's 4 over rad 2. Then rad 2 over rad 2. I end up with 4 rad 2 all over 2. There we go. 2 rad 2. So there's a number of ways. Yes. Okay, so as long as you are getting that same answer, it's like, how do you get to Starbucks? Any number of ways to get there. There's multiple ways we can talk about. All right, so now adding variables. Doing the same thing. What do you think? Sophie?
Okay. You just, for the fancy one, it would be rad x over rad.
Yep. And then I end up with 6 rad x over x. Okay, look at the bottom one is a little bit different. I'm going to simplify first, right? 18 is made up of 9 and 2, and this is made up of a squared and a. So this really becomes 3 rad 2 over a rad a. So what do I have to multiply by? Matthew? Rad a over rad a, and that gives me 3 rad 2a over a squared. What did I do there? Why is that looking different? Yeah, that would be right. I'm going to pull another one out. That should be an A, not a 9. Now, I could also just rationalize, multiply by a cubed, then simplify. So I'm pulling out a 3, I'm pulling out an A, and then when I cross cancel, I'm left with that 3 rad 2a over a squared. Does that make sense? Sophie? I would probably rationalize first as my PowerPoint did it here. What about 21? What are we doing, Josh?
You could find the square root of 5.
And that is 3. And then
3 and 3
cross cancel, and we are left with rad 7. Okay. Now, what would I multiply, rationalize by for the denominator of 22? Sophia? Sure. I'm not sure how they do it. So what do you want to simplify, the denominator or the numerator? Or both? Okay, so 60 is made up of 4.
And 4.
Okay, and the bottom is made up of y squared and x, right? So what would it simplify to? 2
2 rad 15
over.
over y rad x.
So now what am I going to multiply top and bottom by?
Rad x over rad x.
Yep, rad x over rad x. I think that's the way my PowerPoint did it. And then we end up with, keep going, Sophie.
And then you end up with 2 rad 15x over xy.
Good. Okay, questions? All right. Need to look at that for a minute. Okay, so now I think, what do you think we should do first here? Rand, simplify the fraction. So that reduces to what? 1 over 2.
Rad
Okay, rad 1 over rad 2. Right. Oops, that's not what I meant to do. And that's because we can divide top and bottom by 9. Right? And then what would I need to rationalize by?
rad 2 over rad 2.
Rad 2 over rad 2. And then we're left with rad 2 over 2. You guys with me or am I going too fast? Okay, what can I divide out of top and bottom of the next fraction, please? Someone other than these three. Someone other than our math day champion. Second place. Okay, Lilia. I can divide top and bottom by 10, yes. And then I'm left with rad 2/5. Okay, then we can multiply by rad 5 over rad 5. And what do we finish with? What am I finishing with? Rad 10 over, can those be divided? No, not non-radical with radical. Okay, I think for this one, 25, I might almost like, now that it's in there, 30 divided by 15 is what? Rad 2. And x squared divided by x is? X. Boom. Right? I would take these two and these two. Questions? Okay. All right. Again, it's just numbers over numbers. 48 divided by 16 under the radical is a 3. And y to the 7th over y to the 4th is what? Got it? Now, is there any perfect square in there? Yes, Alina. Thank you for reminding me. What perfect square is in that radical?
It is y
Squared times y. And so what does it become?
Then that becomes y rad y.
Y rad 3y.
Rad 3.
Okay? You guys good with that? I can divide a 6 out and I'm left with a 3 here, and I can take 3 a's out and I'm left with a squared here. So 1 over 3a squared under the radical. A squared is a perfect square, so that's a rad 3. Now what? Rationalize, and we end up with rad 3 over 3a. Can I cross cancel the 3's? No, thank you. Okay, questions? Okay, I think that's the last one. I will go into the Okay, let's just stop there. We'll try and discuss this another day, but, okay, we'll discuss it later.